Okay, a woman in a car moving at a constant speed of 20 meters per second approaches and then leaves a sound source. Okay, if the speed of sound in the car is 330 meters per second and the apparent frequencies of the source heard by the woman are f1 and f2 respectively, find the ratio of f1 over f2. Okay, so what information we have? We have the woman in a car. Okay, car moving at a constant speed of 20 approaches and leaves a sound source. Okay, so this is the source, and the woman in a car is the observer. Understand? The woman in the car is the observer. The sound source is the source. Okay. Okay. And then the speed of sound in the car is this one. This is the speed of sound. Okay. Speed of sound. Speed of sound. Yeah. What is this constant speed 20? This is the speed of the woman in the car. So this is the observer. So this is the observer speed. Write that down. This is the observer VO. VO, observer speed. Observer speed. Okay. So now, and the apparent frequency heard by the woman is f1 and f2. Okay. This is apparent frequency. Apparent frequency. That means both of these are observed frequency. Observed frequency 1. This is observed frequency 2. We have 2. Why we have 2? Because one is approaches, one is leaves. Yeah? One is approaches, one is leaves. One is observer approaches, one is observer leaves the source. Okay? Find the ratio between f1 and f2. So, okay, let us draw it out. Let us draw it out. What's happening? Okay, so we have this is the source. This is the source. Okay, let me draw. Okay, so source, and this is the sound source, and then we have the observer moving towards. Okay, this is approaches. We speed, observer speed 20. Okay, and then after that he leaves. Afterward he pass by the sound source, isn't it? Afterward the observer pass by, leaves the sound source. That means it passed by the sound source. This observer velocity 20, yeah, it leaves. So this is the sound source, you know. Okay, sound source. Yeah, the sound source. Okay. Okay, so so here, over here, when it approaches, when the observer approaches, he hear observed frequency. He hear observed frequency FO1. Sorry, FO1. And then after he leaves, put it as FO1. This one is F observed frequency number 2. When he leaves, he heard this frequency. Okay, and the source has source frequency lah. Okay, what's the source frequency? Did he mention? No. Yeah, just put as F source frequency. Okay, when it approaches, he heard this observed frequency, and when he leaves, he heard the observed frequency. Observed frequency 1, observed frequency 2. So you want to find ratio of them. So how are you going to do? So Doppler effect. This is about Doppler effect. Doppler effect. Remember, no matter this is about the source, moving source. This is about the moving observer. Okay, you look at here. Look at here. No matter is source moving towards the observer or observer moving towards the source, as long as they approaches each other. If they approaches each other, source approaches the observer or observer approaches the source, the observed frequency always increase. Observed frequency always increase. Understand? If Vs is at below, we minus. If Vo is at the top, we plus. So that the observed frequency always increase. Go back to your concept video. I already lecture about this. I already explained about this. Go back to the concept videos. Concept videos. And if, let's say, the source moving away, or the observer moving away, means the source leaving the observer, or the observer leaving the source. When they are moving away from each other, source moving away from observer or observer moving away from source, no matter who leaving who, the observed frequency should always decrease. Okay. So as long as they approaches, no matter if source approaches or observer approaches, observed frequency always increase. If they are moving away from each other, let's say the source moving away or the observer moving away, the observed frequency should always decrease. So to make the observed frequency decrease, Vs at the below we plus, Vo at the top we minus. So to make the observed frequency decrease. Okay? So what I can say is, in a nutshell, as long as approaches, no matter who approaches, source approaches or observer approaches, observed frequency always increase. Observed frequency always increase. When they are, let's say they are, okay, wait a second. I think I need to make this more appealing. Okay, if let's say they are moving away, as no matter who moving away, the observed frequency always decrease. That's the most simplest tips what I can provide to you. This is the simplest. As long as who approaches who, observed frequency should always increase. And if they are moving away from each other, no matter it's observer moving away or source moving away, observed frequency should always decrease. Remember this only. This is the tips. This is the only tips. Okay, so now let's investigate this case. Talking about FO1, let's form the formula first. So to find the FO1, observed frequency, okay, the Doppler effect equation is this. How to derive from the source frequency, So we have this. Okay, now who is moving? Is it the source moving or observer moving? Observer moving, isn't it? Okay, look at the equation. Where is the observer speed? At the top, isn't it? Vo at the top, Vs at the bottom. That's only you have to remember. So always remember Vo at the top, Vs at the bottom. Right now, we only have Vo. Vs is 0. Because the source is not moving. The source is stationary. Only the observer moving. Only the observer has velocity. So we only have Vo at the top. Understand? We only have Vo at the top. So we only have Vo at the top. Vs is 0. Okay? So now, this is moving up. This is approaches, right? Observer approaches. Observed frequency increase. So the observer should hear higher observed frequency. It should increase because approaches. So approaches increase. So here at the top here, we need to make it bigger. This thing at the top here, we need to make it bigger. Understand not? This thing at the top, we need to make it bigger. So to make it bigger, we need to plus. Remember? That's it. Okay? How about this one? If observer moving away. No matter who moving away. Is source moving away or observer moving away, the observed frequency should decrease. So write that formula again. FO2 equal to source frequency. Yeah, here the source frequency. Now, which one has velocity? Still the observer has velocity, right? We only have VO. We don't have VS. VS is 0. So at the bottom, we don't have VS. So we only have VO at the top. So write down the formula there. We only have VO. We don't have VS. That's it. Okay? But now is observer leaving. Observer leaving, that means observer frequency should decrease. Observer frequency should decrease because it's leaving. When moving away, leaving, observer frequency should decrease. Yeah? No matter is, I just tell you again, is no matter is who approaches who, yeah, is source approaches or observer approaches, source frequency should, the observer frequency should increase. But if no matter who leaving who, source leaving or observer leaving, the observer frequency should always decrease. Understand? So now this observer leaving means observer frequency should decrease. So to decrease thing, so the top here, how to manipulate the top? So if leaving observer frequency decrease, so decrease means the top here need to decrease, isn't it? Need to decrease. So I need to minus. That's it. That's the formula. That's the key. Yeah, we minus so that the top here become smaller, so the observer frequency becomes smaller. Here we need to plus because we need to make this thing bigger so that the observer frequency bigger. Understand? That's the trick. So okay, let's continue putting all our value. So we have this one, the speed of sound. This is the speed of sound, 330, which is this one, 330, and then plus with VO is 20. VO is 20. Put 20, and then over 330 Fs, and this one is 330 minus 20, and then over 330 Fs. Okay, so now put into a ratio. We want F1 over F2. So F1, FO1 over FO2. This is what we want to find, isn't it? FO1 over FO2. So what do we get? Okay, I think second, this one. Okay, this one we need to change it. This one become what? This one become 350 over 330. 350 over 330, and then 310 over 3. Okay. So okay. So this one. So we can substitute here. So at the top here we have what? We have this one. We have this. And then at the bottom we have this, right? Okay. So we can cancel, and at last we have what? We have 350 over 310, which is, let's find out, which is 350 divided by 310, and we get answer 1.13. That's it, 1.13. Is there answer? That's the answer. Okay, so that's the answer. We got the answer already. So the answer is 1.13. This one. Okay? Understand? That's it. Remember these tips only. No matter it's source approaches or observer approaches, source approaches observer or observer approaches source, observer frequency should always increase. When source moving away or observer moving away, the observer frequency should always decrease. That's it. And then you can do it. Yeah. Plus and minus. Look at where is you use VO or VS. If VO at the top, to make this increase, we plus. If VS at the below, we minus to make things smaller so that observer frequency increase. So plus and minus. Look at what happened to the observed frequency first. Okay, so that's it for this question. Okay, bye bye.